Now we're ready to start looking at the non-homogeneous equations, and the method we're going to use is initially here is called the method of undetermined coefficients. And I want to introduce this idea to you with a rather simple equation. Y double prime minus 3y prime plus 2y equals to 4e to the negative 3x. Alright, so you see that the right hand side is non-zero. It's a function. Often we call this, refer to it as q of x on the right side of the equation. The left side of the equation, again, is a second order linear differential equation with constant coefficients. Well, our first step is to solve for the complementary solution, and that's what we've been doing up to this point. So if we look at the left side here and write out the characteristic equation, m squared minus 3m plus 2 equals to 0, and we can solve this one by factoring. It's m minus 1, m minus 2 equals to 0. So the roots are 1 and 2. This allows us to write out the complementary solution, which I'm going to write this way. Y complement, so it'll be y with a subscript of c, will be c1 e to the x plus c2 e to the 2x. So you see that I basically ignored my right hand side and treated this equation as if it equaled to 0. I solved it and I got my complementary solution using the roots of the characteristic equation. Well, that's only part of the general solution to the problem. Now we focus on the right hand side, the 4e to the negative 3x. So I'm going to erase this and move that up there so we have a little more room to work. We're now ready to find the rest of the solution to this problem that incorporates the non-zero part on the right side, the 4e to the negative 3x. And that aspect of the solution is called the particular solution. And we notate it y subscript p. Now I'm going to let my y particular be a e to the minus 3x. And what we're going to do is figure out what a has to be in order to fit into this equation. So where is this all coming from? Well, first of all, notice that with x and 2x, these exponents do not appear on the right hand side. And if they did, if we had an e to the x or e to the 2x over here, that would make it more complicated. And we'll deal with that later on, that issue later on. So, but you look at the particular solution here. If I take derivatives, y particular, I'll just get terms that contain e to the negative 3x. So let's go ahead and do that. The first derivative, my particular solution, is negative 3a e to the negative 3x. And my second derivative would be 9a e to the negative 3x. So what I'm going to do is plug all these in to my original differential equation. And that gives us, I'll write it out here, y particular double prime minus 3y particular prime plus 2y particular would be equal to 9a e to negative 3x, and then negative 3 times this term, minus 3 times negative 3 a e to negative 3x, and then plus 2y prime plus 2a e to negative 3x, and that equals to the right hand side, which is 4e to the negative 3x. So let's go ahead and distill this down. When I look at this part of this equation here, I'm going to have 9a plus 9a and plus 2a, so this is 9 plus 9 plus 2 is 20a. I end up with 20a e to the negative 3x is equal to 4 e to the negative 3x. So what's that tell you? When you solve for a is going to be 1/5. Is that obvious? You can cancel e to the minus 3x by division, and 28 equals to 4, so a would be 4 over 20, or 1/5. So that allows me to write the actual solved particular solution would be 1/5 e to the negative 3x. Well, let me erase this and I'll make my final point on this. We'll write out the complete solution. So here we are. We solved for the homogeneous case as if the right side was 0. We got the complementary solution. We formed a particular solution with letter A, and we solved for A. That was the undetermined coefficient, was A. We found out that A was 1/5. And so we have a particular solution, 1/5 e to negative 3x. This means that the general solution ends up being the sum of these. Let me write that out and I'll explain that. So the general solution, y, would be c1 e to the x plus c2 e to the 2x plus 1/5 e to the minus 3x. So why do we do that? Why do we add those together? So in essence, I'm saying that the general solution, y, is the sum of the complementary solution and the particular solution. Well, if I were to plug this back in, the complementary solution, back into my original problem, the whole left side will equal to 0. And so when I add in the particular solution, it will, and to this equation, it will add up to the right hand side, 4e to the minus 3x. So what's nice about this, it captures everything we need for the most general solution we can come up with. And as usual, with a second order equation, you expect two constants of integration, C1 and C2. So it takes into that account. In any event, that's it's kind of in a nutshell the method of undetermined coefficients. And I'm going to work a few more of these as examples before we start looking at some exceptions to the rules here we have to deal with.